Okay, Wildcats. So today we're looking at Thursday, January 25th, solving square root equations on page 48. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, solving square root equations. Solving square root equation steps. Step 1, isolate the square root. Step 2, raise both sides of the equation to the power of 2. Step 3, simplify and solve. Step 4, check for extraneous solutions. All right, so if you would, finish up your notes. All right, now your notes are updated. Let's take a look at the examples. Example 1. All right, solve each equation. Remember to check for extraneous solutions. Example 1. So step 1, isolate the square root. The square root's isolated. So step 2, square both sides. Okay, so the square root and squared becomes the power of 1, so you're left with 2x equals 6 squared, which is 36. Divide both sides by 2, so x equals 18. All right, so you need to check. So to check, I want you to actually write the word check, so I know that underneath the word check is your check work, okay? So to check, you plug 18 back into the original equation, so that's the square root of 2 times 18 equals 6. So if 18 is correct, this will be a true statement. Well, 2 times 18 is 36, so the square root of 36 was 6. Well, the square root of 36 is 6, so 6 equals 6. So this is checked. All right, example 2. All right, isolate the square root first. So we're going to add 3 to both sides. Okay, so that becomes 0. So then, and I'm actually going to rewrite this as a square root. Actually, no, I'm going to leave it like that because I know an upcoming test is probably going to put in that form. So that's 2x to the power of 1/2 equals 8. Okay. So we're going to raise each power by 2. So I'm going to raise this by 2 and this by 2. Okay. Well, here you multiply. So 1/2 times 2 is 2 over 2, which is 1. So that just becomes 2x. And then 8 squared is 64. Divide both sides by 2. So x equals 32. All right. And then you want to check. Let's see if I can zoom in a little bit there. And again, she wants you to write the word check above your check work. So we're going to substitute 32 in. So then that's 2 times 32 raised to the power of 1/2 or minus 3 equals 5. Well, 2 times 32 is 64, and I can rewrite to the power of 1/2 as a square root. So square root of 64 minus 3 equals 5. Well, 64 square root of 64 is 8. And 8 minus 3 is 5, so 5 equals 5. So this is checked. All right, let's move on to example 3. All right, example 3. Again, we want to isolate this root, so we're actually going to multiply both sides by 3. Well, if you multiply this by 3, that becomes 3 divided by 3, which is 1. So then that's the square root of x plus 5 equals 4 times 3 is 12. All right, now we're going to square both sides. That becomes the power of 1, so you're left with x plus 5 equals 12 squared is 144. Subtract 5 from both sides, x equals 139. And again, you want to check. So you substitute 139 back in for x. So that becomes the square root of 139 plus 5 divided by 3 equals 4. Well, 139 plus 5 is 12. Or not 12, I'm sorry, 144. So that's the square root of 144 divided by 3 equals 4. Square root of 144 is 12. 12 divided by 3 equals 4. So 4 equals 4. So this is checked. All right, let's look at example 4. All right, the square root is isolated. So the next step is we're going to square both sides. So that's then x minus 4 squared is x minus 4 times x minus 4 equals, this becomes the power of 1 equals x minus 2. So then we FOIL, so x times x is 1x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. And that equals 1x minus 2. Now you could have drawn a box off the side, but as you can see, it kind of, it takes up way too much space to draw a box here. So you want to use the foiling when you can. So then next step is we're going to simplify and solve. I'm going to go and subtract 1x from both sides and add 2 to both sides. Notice that I put the x with the x's and the 2 with the number. So that becomes 0, 0. You get 1x squared minus, let's see, that's negative 8 minus 9x plus 18 equals 0. And so then you want to factor. And I think we need one more line here. So 2 parentheses. So you think, what numbers multiply to give you 18 and combine to be negative 9? And so that would be minus 3 and minus 6. You set them equal to 0. So x minus 3 equals 0. You add 3 to both sides. So x equals 3. Then you have x minus 6 equal to 0. Add 6 to both sides. X equals 6. All right, and then you want to check. Now, I didn't use all of my space for example 2, so I'm actually going to use space from there to check. You're going to need a little space because you need to check both numbers. So we substitute 3 in, so that's 3 minus 4 equals the square root of 3 minus 2. 3 minus 4 is negative 1 equals 3 minus 1 is 1, so that's the square root of 1, which -1 does not equal 1. So we say that x equals 3 is an extraneous solution. All right, so now let's check the next one. So then that's 6 minus 4 equals the square root of 6 minus 2. 6 minus 4 is 2. 6 minus 2 is 4. Square root of 4 is 2. So 2 equals 2. So x equals 6 is a solution. All right, let's look at example 5. All right, so it looks like the square root is isolated. So now we raise both sides to the power of 2. So that becomes the power of 2, power of 2. So that's x minus 12 times x minus 12 equals, now these multiply, so 1/2 times 2 is 1. This just becomes the power of 1, so that's just 16x. So we distribute, or we FOIL, so x times x is 1x squared. X times -12 is -12x. -12 times x is -12x. -12 times -12 is a positive 144 equals 16x. Now, it appears my pencil is getting dull, so give me like 8 seconds, and I'll get a new pencil and be right back. All right, back with the, look at that pencil. That's a nice pencil. And if you're going to get a pencil, always go with the American pencil. It's the #1 quality pencil made in America. All right, so we're going to subtract the 16x from both sides. And notice I put it with the other x's. Looks like we might need some more lines. All right, so that becomes 1x squared. That's, let's see, -24, -40x. And then that's plus 144 equals 0. All right, so we really need to think about all the numbers that make positive 144 and combine to be -40. And the fastest way to find those is use your calculator. So if you use your calculator and you go to new document, add graph, and we're going to take, and let me lighten up the screen a little, or darken up a little bit. All right, 144 divided by x. Enter, Control T. This will give us all the combinations of 144. Okay, that's not going to combine to be 40. That's not going to combine to be 40. Neither will that. Aha. 4 and 36 will multiply to give you 144 and combine to be -40. So there's your factors. So we have x minus 4 and x minus 36 equal to 0. So x minus 4 equal to 0. Add 4 to both sides. X equals 4. Okay, x minus 36 equal to 0. Add 36 to both sides, x equals 36. All right, and then you want to check. So let's try with 4. So 4 minus 12 equals, and I can just rewrite that as the square root of 16 times 4. Well, 4 minus 12 is going to be a negative 8. And the square root of 16 times 4 is a positive 8. Since that's a false statement, we know that x equals 4 is an extraneous solution. All right, so now let's check positive 36. So that's 36 minus 12 equals the square root of 16 times 36. Well, 36 minus 12 is 24. And the square root of 36 times 16, or 16 times 36, is 24. So we know that that checks, and so x equals 36 is a solution. All right, so now let's look at example 6. The square's not isolated, so we're going to subtract 8 from both sides. So then you get the square root of x equals negative 6. We square both sides. So then you get x equals, and whenever you square a negative number, it should be in parentheses, positive 36. Okay, and then we're going to check. So then we substitute 36 in, so that's a square root of 36 plus 8 equals 2. And so we see that that's 6 plus 8 equals 2. That's 14 does not equal 2. So we know that x equals 6 is an extraneous, which is that x equals 36 is an extraneous solution. All right, now let's take a look at example 7. All right, so the square roots are as isolated as can be, so we're going to square both sides. So that becomes the power of 1 to get x plus 4, and this would be 5 square root of x minus 20 times 5x minus 20. Okay, nothing we can do with x plus 4 yet. 5 times 5 is 25. Now, when you multiply these, you have to think about another way to think about this. This is actually to the power of 1/2, and this is to the power of 1/2. Well, when you multiply exponents, you add them, so 1/2 plus 1/2 is 1, so this just becomes x minus 20. All right, so then we have 1x plus 4 equals, distribute the 25, so 25x minus 25 times 20 is negative 500. So let's start by subtracting 1x from both sides. So you get 4 equals 24x minus 500. Add 500 to both sides. You have 504 equals 24x. Divide 24 by both sides. X equals 21. All right, and so then you want to check. All right, so you plug in 21, so that's 21 plus 4 equals 5 times the square root of 24 minus 20. Well, that's 25 equals 5 times 24 minus 20 is 4. Square root of 4 is 2. Oh, wait a second. Hold on. This was a square root of... that's much better. And that's not 24, that's 21. So let me do that again. And that's something, I'm glad I made that mistake there, is that if they don't check, sometimes you want to go back and look at the original equation and say, did I put the number correctly into the equation? So that's why you want to make sure it's not extraneous, that it could be an actual correct solution. Okay, so in this case, 21 plus 4 is 25, square root of 25 equals 21 minus 20 is 1, so square root of 1. Well, square root of 25 is 5. Square root of 1 is 1, so 5 equals 5. So x equals 21 is the solution. All right, last example. All right. So the square root's isolated, so now we want to square both sides. Okay, so then that's 4 plus 1x times 4 plus 1x equals, that becomes the power 1x plus 4. So then you FOIL, 4 times 4 is 16. 4 times 1x is plus 4x. 1x is plus 4x. And 1x times 1x is 1x squared. Equals 1x plus 4. So we're going to subtract 1x from both sides. And subtract 4 from both sides. Notice I keep the x's with the x's and the 4 with the number. And I'm also going to rewrite this so that the x squared, it's easier to factor when the x squared is in front, and you go from highest exponent to lowest. So that's 1x squared. 4x and 4x is 8x, minus 1 is 7x. And then 16 minus 4 is 12. Equal to 0. All right, so you want to factor. We know x and x. And we want to find all the combinations to make 12 and combine to be 7. So again, you're going to want to use your calculator. So I'm going to go to New Document, No, Add Graph, and I'm going to take 12 divided by x, Control T, and so I'm looking for all the factors. Well, we know all these are going to make 12, but we're looking for 7. That doesn't make 7. That doesn't make 7. 3 and 4 make 7, so it's x plus 3, x plus 4. So x plus 3 equal to 0, x plus 4 equal to 0. Subtract 3, so x equals -3, and subtract 4, x equals -4. All right, and then we want to check. So then that's 4. Let's check -3 first. So that's 4 minus 3 equals the square root of -3 plus 4. 4 minus 3 is 1. -3 plus 4 is 1. Square root of 1 is 1. So this checks. 1 equals 1. Okay, so now let's check -4. So 4 minus 4 equals the square root of -4 plus 4. 4 minus 4 is 0. -4 plus 4 is 0. Square root of 0 is 0. This checks. Both -3 and -4 are solutions. All right. So with that, you have two options. If you had some trouble with some of the examples, you can wait till class and I'll go over those examples with you. Or if you understood all the examples, you can start working on the assignment. Either way, have a wonderful Wildcat